Bright Duty. Every student matters.
Now, in case of isotopes and isobars, we had already seen the differences between the isotopes and isobars. Now, let us do some questions related to that. For the symbol of the protium, that is H, deuterium and tritium, tabulate 3 subatomic particles found in each of them. Now, for doing that, first let us write down their formulas. That is, this is what protium looks like. So because the atomic number is only 1, so what will be its electronic configuration? K, L, M. So the electronic configuration of protium is going to be only 1. Now what about deuterium? Deuterium is 2 and 1. So the electronic configuration for deuterium is again going to be 1 because the atomic number is 1. Whereas in case of tritium, what would it be? In case of tritium, it's going to be 3 as the mass number and the atomic number is again same because these 3 are the isotopes. So as because they are the isotopes, they are going to have the same atomic number but different mass numbers. In case of tritium, what would be the electronic configuration? The electronic configuration is going to be again 1. So we see in the K shell there would be 1 electron each. So this is the electronic configuration or of protium, deuterium and tritium. Now if we want to find out what are the subatomic particles, then in case of protium, protons, how many protons would be there? Because the atomic number is 1, so the number of proton is also going to be 1. Electron is also going to be 1 because the number of proton is equal to the number of electron. Whereas the number of neutron is going to be 0 in this case. Why is it 0? Because the mass number is 1. So 1 proton, 0 neutron. Whereas in case of deuterium, what happens? The number of proton is going to be 1 because the atomic number is 1. Electron, we know that number of electron is equal to the number of proton. So electron is also going to be 1. But what about neutron? Neutron would be the mass number minus the atomic number. So because we have mass number is 1 as 2 and the atomic number is 1, so mass number minus atomic number is going to give us the number of neutron, which is equal to 1. In case of tritium, proton 1 because atomic number is 1, electron 1 because the number of proton and electron is going to be same, whereas the number of neutron will depend on the difference between the mass number and the atomic number. So as because the mass number is 3 and the atomic number is 1, so 3 minus 1, that is equal to 2. So we see that in case of tritium there are 2 neutrons, in case of deuterium there is 1 neutron, whereas in case of protium there is no neutron. Okay, let's go to the second one. Write the electronic configuration of any one pair of isotopes and isobars. Now here, as you know, what are isotopes? Isotopes are those atoms of the same element which have different mass numbers but the same atomic number. So we can take carbon 12 and carbon 13. So what would be its electronic configuration? As because the number of, this is a pair of isotopes. So as because the number of electron is equal to the number of proton, so here the atomic number is going to be 6. So in both the cases the electronic configuration would be 2 and 4. Why is it 2 and 4? Because there are 6 number of electrons. So 2 goes in the first shell, that is the K shell, and the remaining 4 goes to the L shell. So this is the electronic configuration of carbon in both the isotopic form. Whereas if I take a pair of isobars, now in pairs of isobars, let us take potassium and calcium. Now we know that isobars are those atoms of different elements which share the same mass number, but the differences comes in their atomic number. So if I have to write down the electronic configuration of potassium, then it's going to be K, L, M, 2, 8, 8 and 1. That means 2 plus 8, 10, 10 plus 8, 18 and 18 plus 1, 19. So in the outermost orbit, in the end shell, there is 1 electron available. Whereas if I write down the electronic configuration of calcium, whose atomic number is 20. So it is going to be 2, 8, 8 and 2. So as the electronic configuration rule goes, in the first shell 2, second shell 8, third shell 8, whereas in the nth shell it's going to be 2 electrons. So 2 plus 8 10, 10 plus 8 18 and then the rest of the remaining 2 goes to the n level. So this is the electronic configuration of a pair of isotopes and a pair of isobars. Clear? Next question, if bromine atom is available in the form of say 2 isotopes, 79 bromine 35 of the percentage of 49.7% and 81 bromine 35 which is available to 50.3%. Calculate the average atomic mass of bromine. Alright, let's do it. So we are going to take 79 into how many percent? 49.7% divided by 100 plus, next we have 81% into 50.3% divided by 100. Alright, now here it says that the total bromine that is available will consist of these two isotopic form, out of which the 79 mass number would be of the range of 49.7%, whereas 81 mass number of bromine isotope will have a percentage of 50.3 out of the 100%. So let us calculate what is it going to be. It's going to be 3926.3, you can calculate and find out, plus 4074.3 divided by 100. So this is simple LCM, 39.263 plus 40.743. So if we add up, it's going to be 80.06 unit, which is equal to approximately 80. So the average atomic mass of bromine is going to be 80 unit. And this is what is taken as the average mass of bromine, even though they exist in two isotopic forms of 79 bromine and 81 bromine. Clear? We have a similar question like this. Suppose the average atomic mass of a sample of an element is given to be 16U. So the atomic mass is already given. You just have to find out the percentage of these two isotopes that are present. Now for that we just need to assume that let X be the percentage of 16x8 and so out of 100, 100 minus X would be the percentage of 18x8. Clear? So taking these things into account, let us solve it. We are going to take 16 into x by 100 plus 18 into minus x by 100. Okay, which is average is coming to be 16.2u, or 16x by 100 plus 1800 minus 18x, which is equal to 100. 16.2, or I can say 16x plus 1800 minus 18x, which is equal to, if I transfer this 100, then it's going to be 16.2 into 100, or minus 2x plus 1800 is going to give us 16.2 into 100, or x is equal to 180 divided by 2, which is equal to 90. Clear? So it is going to give that if x is equal to 90, that means 16x8 is equal to x, what we present, which is equal to 90, and 18x8 is equal to 100 minus x, that is 100 minus 90, which is equal to 10. So we are going to have 16x8 90% and 18x8 10%. Clear? Next question. Explain with examples atomic number, mass number, isotopes, isobars. Okay. So what is the atomic number? So atomic number is the number of protons present in an atom. So we can have oxygen as an example with atomic number 8. We can have hydrogen with atomic number 1, helium with atomic number 2, so on and so forth. So the number of electrons or the number of protons present in an atom tells you about the atomic number. Whereas when it comes to mass number, in case of mass number, it is number of protons plus the number of neutrons. That is the nucleons, the number of protons and neutrons that are present in the nucleus. Clear? So in this case, we can have oxygen. The mass number, if we write, the mass number is 16. That is, we have 8 protons and 8 neutrons, which is giving us 16 as the mass number. Similarly, if I take helium, the mass number is 4, that is 2 proton and 2 neutron, which gives you the mass number of 4. Clear? Next question comes, what is an isotope? As I had already explained you in previous questions, that isotopes are atoms of the same element which have the same atomic number but different mass numbers. Like for example, I can have hydrogen, this is protium, deuterium, tritium. So we have isotopes with the same atomic numbers, whereas the mass numbers are different. Next question, what are isobars? Isobars are atoms of different elements having the same mass number but different atomic number. For example, we can have potassium and calcium. So in these two cases, you see they are isobars of atoms of different elements. Their mass numbers are same but their atomic numbers are different. Next question 5. Give 2 uses of isotope. Now what are isotopes used for? Isotopes are used for treating cancer. Like for example, cobalt is used in radiotherapy for treating cancer. Okay, for treating cancer. Whereas we can have another example as uranium. Radioactive isotope of uranium is taken for radioactivity. Okay, for the generation of radioactivity. Next, composition of the nuclei of 2 atomic species X and Y are given as under. So we have X with number of protons and neutrons. Give the mass number of X and Y. What is the relation between the species? So if I write X, we know we write down the atomic number bottom, and this is going to be, for in case of X, 6 plus 6, that is the mass number, that is 12x6. Similarly, for the second case, that is y, it is going to be 6 plus 8 and 6. So this is going to be 14x6. What is the relation between these two species? These two species are isotopes. Why isotopes? Because they have the same atomic number but their mass numbers are different. For the following statement, write T for true and F for false. J.J. Thomson proposed that the nucleus of an atom contains only nucleons. This is false because he said nothing about the nucleus. B. A neutron is formed by an electron and proton combining together. Therefore, it is neutral. Neutron. False. There is no combination. Neutron is a particle and it is not charged. That's why the electron and proton gives it a zero charge. The mass of an electron is about 1 by 2000 times that of proton. This is true. We know that electrons are 1 by 2000 times less weight than proton. An isotope of iodine is used for making tincture of iodine, which is used as a medicine. Very true. It is used as a medicine because it has got medicinal value. It accelerates the level of healing. Number 16. Isotopes of an element have the same physical properties, different chemical properties, different number of neutrons, different atomic numbers. So we know that the atomic numbers are same, so D cannot be taken into account. Different number of neutrons, yes, different number of neutrons because their atomic masses are different, and we know mass numbers is equal to the number of proton and neutron. So because the atomic number are same, so the number of proton is going to be same, only the difference comes with the number of neutrons.
Let's do this question. We need to complete the table. The atomic numbers are given, mass numbers are given, and we need to find out the number of neutrons, protons, electrons, and write down the name of the atomic species. So let's start with the first one. This is the first one which is given. Atomic number is 9 and the number of neutrons is given. We need to fill in the blanks. So what would be if atomic number is 9, that is the number of protons. So number of proton here would be 9. In a neutral atom, we know that the number of electron and proton are same, so it is also going to be 9. So what would be the mass number? The mass number is going to be the number of proton plus the number of neutron, which is going to be 19. So this signifies fluorine. So the atomic species is fluorine. Next, the atomic number is given to be 16, mass number 32, and we need to find out the number of neutrons, protons, and electrons. Now, if atomic number is 16, then the number of proton will also be 16 because the atomic number is equal to the number of proton. Then, in a neutral atom, the number of proton and electron are same, so this is also going to be 16. We know that mass number is equal to the number of proton plus neutron. So if number of proton is 16, then the number of neutron is also going to be 16. So we see in this case the neutron is 16, number of proton is 16, number of electron is 16, and thus it is the sulfur atom. Number 3, mass number is given to be 24, number of proton is 12. So if number of proton is 12, the atomic number is going to be 12. If atomic number is 12, then the number of electron is also going to be 12 because in a neutral atom, in a normal atom, the number of proton and electron are same. Now we can find out what is the number of neutron. Definitely it is going to be 12 because 12 plus 12 is 24, which is the mass number, and thus this is the atom of magnesium. Next, number 4 is the mass number is 2, the number of proton is 1. So number of proton 1 means the atomic number is 1. The atomic number, that is the number of proton, is 1 and the mass number is 2. So definitely the number of neutron is 1, and in a neutral atom or a normal atom, the number of proton and electron are same. So here, because the mass number is 2 and the atomic number is 1, so definitely it is the deuterium, the isotope of hydrogen. The last one, the mass number is 1, the number of neutron is 0 and the number of proton is 1. Now, and because the number of proton is 1, so definitely the atomic number is 1 and the number of electron would also be equal to 1 because in a neutral atom the number of proton and electrons are equal, and here because the number of neutron is 0, definitely it is one of the isotope of hydrogen, which is protium. So we see the species are fluorine, sulfur, magnesium, deuterium and protium. So this is how we had completed the table using our knowledge of atomic number and mass number and the relation of atomic number with the mass number.